that I'll start off with before I turn it over to Alex, our speaker today, is we have been receiving a few criteria change requests of the UFC, and I'll give a little bit of history on what happened and what we're doing. People are asking about this baseline and talking about the difficulty of it. What I will say is the National Defense Authorization Act of 2022 requires us to adopt this baseline. That's a little bit of a unique occurrence. Typically, there's some processes where the DOE evaluates criteria and does a recommendation on what types of adoption. And also USACE does that too. We research when should we adopt certain codes and criteria. So there's certain processes. But because it was in the NDAA 2022, we don't have that ability to make those decisions. ASHRAE 90.1 2019, that specific year was called out in that law. So because of that, we worked to adopt it. The UFC, the Tri-Services Sustainable Functional Working Group, incorporated that into UFC. So you don't have to look up the NDAA. You don't have to look up 10 CFR 433 unless you would like to learn more about it, because we incorporated that into our criteria, the Unified Facilities criteria. And we had a very specific adoption date of April 7th, which was just approximately, 14 days ago? I don't know. I'm not going to do the math. But a few days, this month, all of our projects that are starting design after that date of April 7th must utilize the ASHRAE 90.1 2019 baseline. So that being said, that gives us a little bit of a background of why we're having to do it and that we are required to do it. So I'll talk a little bit about the speaker. Alex Ortiz is a COS mechanical engineer from the Savannah district. And he is he's been working with the COS team for many years. He has worked for this position for just over a year after spending over 3 years in the private sector in Pensacola. And Alex is pending licensed professional engineer and ASHRAE certified HVAC designer. With that, Alex, I'll go ahead and turn it over to you.
Thank you. Yes, so yeah, my name is Alex Ortiz, and I worked on this with Sara Murphy, who is the COS architect in the Savannah district, as well as Bill Durham and Jonah Phillips with the Mobile district, and they were also mechanical engineers. So just to kind of go over a brief agenda of what I'll be talking about today, the summary of changes between ASHRAE 90.1 2013 and what we will be moving to in ASHRAE 90.1 2019. And then I will go more in depth with our analysis that we worked on with the Mobile district and the results of that analysis as well, and then the design and cost impacts that we found from the research that we did and the energy modeling. And lastly, I'll touch on any additional information which wasn't covered in our analysis. So brief summary of changes. We didn't go too much in depth with a lot of these changes, but the main one that we did cover in our analysis was this new compliance path. So in ASHRAE 2013, as many of you know, there are two performance paths with the prescriptive and the performance path. But with the introduction of 2016 and continued on to 2019, a third compliance path was added, and this will be important for meeting the requirements of the CFR and subsequently the UFC as well. Another change that was added is a new climate zone. And as you can kind of see in this slightly blurry map, is it covers not any of the US territories, but a lot of South America and Africa. So it may or may not affect some projects. None of the ones that we looked at were in this new climate zone. There are also some new mandatory as well as prescriptive requirements. The mandatory provisions are required of all compliance paths, with the prescriptive requirements consequently only required in the prescriptive path. There are also new commissioning requirements as well, which are summarized in each chapter and is gone into more detail with the Appendix H if anyone wants more detail into these new commissioning requirements. Lastly, replacement HVAC equipment is now required by 90.1 to meet a lot of the same requirements as new HVAC equipment. So this will affect any renovation projects or projects that require replacement of existing HVAC equipment. So to kind of give a brief overview of some of the mandatory provisions and the changes between 2013 and 2019, the air leakage from doors and vestibules, there are a lot of new requirements established, and this is also kind of related to the new commissioning requirements as well, just testing the air leakage from doors and vestibules. And then on the HVAC side of things, ductwork insulation and HVAC efficiency, new updated requirements, which kind of fall in line with each of the previous versions of ASHRAE. They streamline the ductwork insulation table to be a little more clear in terms of just which spaces, which climate zone, what's the minimum insulation requirement. And none of these are drastic changes. I mean, these are just kind of a step above the previous version of ASHRAE. And then same thing kind of goes with the water heater equipment efficiency requirements, as well as transformer efficiency and motor efficiency. Now, some additional requirements which aren't necessarily numerical efficiency requirements are going to kind of lighting control and as well as HVAC controls. There are new requirements there, such as vestibules, automatic daylight control for lighting, emergency egress lighting. We didn't go into too much detail in our analysis looking at these, but it is worth reading 90.1 if you want a more in-depth look into some of these changed requirements. So similar to the mandatory provisions, the prescriptive requirements were updated as well. And this kind of covers more building envelope and fenestration requirements. And similar to the HVAC and lighting, it's just a step above the previous version of ASHRAE in terms of better U factors and solar heat gain coefficients. A new chilled water coil temperature difference was established as well, which will affect any projects with chillers that choose to take the prescriptive path of compliance for ASHRAE. In addition, a increased minimum threshold for energy recovery and new HVAC control requirements, which again only apply to the prescriptive path. So looking at this new compliance method, so previous versions, as mentioned, there was only the performance path and the prescriptive path, but now there's a third path in the performance rating method. The previous prescriptive remained the same, and the older performance path became the energy cost budget. So this new performance rating method kind of arose from the Appendix G, which many people will probably be familiar with. And this was originally designed for a beyond code compliance paths such as LEED, IGCC, and other sites that other beyond code standards. But this new performance rating method is a direct ASHRAE compliance method which involves a new performance cost index and subsequently a performance cost index target, which is a part of a new equation that is used to determine compliance of a design against a baseline version of that same building. So compared to the energy cost budget, which was previously the performance path, this new path takes the minimum prescriptive requirements from the 2004 version of ASHRAE versus the energy cost budget, which just takes the minimum prescriptive requirements of the current version of ASHRAE. So you would think that it would be easier to meet this path of compliance since it's using older, worse efficiencies from 2004. However, as I'll get into in more detail with our methodology and our analysis, they apply certain factors and change the equation, which make it slightly more difficult to achieve compliance with this new PRM path of compliance. So the CFR, the Energy Efficiency Performance Standard, Title 10, Part 433, and the UFC 1-200-02 specifically list these two requirements to meet ASHRAE 90.1 2019, and if life cycle cost effective, achieve 30% energy levels below the baseline established in Appendix G, which is now the performance rating method. And as Ed previously mentioned, this goes into effect early April of this year, which is a couple weeks ago. So for any new projects, this will now go into effect. So the new equation listed in the CFR uses this new performance cost index and the performance cost index target. So these two numbers are established in ASHRAE and are kind of gone into more detail in ASHRAE, but it's basically looking at the proposed building model energy consumption and then the baseline model energy consumption. And these numbers take into account the receptacle and process loads, as well as the HVAC loads and lighting loads. However, one new addition is that there are some exceptions for the receptacle and process loads that go into this equation. So any energy intensive process loads, this includes training simulators, healthcare equipment, waterway shipping locks, those sort of mission specific process loads do not go into this equation. So previous requirements, there was a different equation and it did not include receptacle loads into this equation. So I'll discuss this in more detail the further I get into the PowerPoint, but for now, that's kind of a brief overview of what the CFR is now saying. So to kind of look at where we started with the analysis. So we took the design of a couple sample projects and then compared it versus the 2013 baseline, and we compared it against the 2019 performance rating baseline as well. So the sample projects we looked at, there's a battalion headquarters in Fort Benning, a company operations facility in San Antonio, as well as a hangar that the Mobile district looked at the Hunter Army Airfield. So as you might notice, all three of these buildings kind of fall within the climate zone 2A to 3A, so all warm to mild humid climates. We did not look at any cold climates, so there is a smaller sample size here in terms of what we looked at, but I'd imagine that our results would be pretty similar climate zone to climate zone. As for what we use to perform this analysis, we use the Train Trace 700 energy modeling software, and we use the local utility rates as well from the each of the bases. So in the previous version of the CFR in 2013 of 90.1, the performance percentage improvement equation was fairly simple. I mean, it basically took the difference between the baseline building and the proposed building and divided that over the baseline building, taking out the receptacle loads. So the 2019 kind of redid that and used this new performance cost index and the performance cost index target, which, as you can kind of see in the below equation, they do include the receptacle and process loads and also include this new building performance factor, which is dependent on the climate zone and the building type and is gone over in this table here. So in 2016, they released this. They ran some analyses of their own, found some errors or some changes that required a new version of this table, which they updated in 2019. And since they put out 2019, they have since released another addendum, which included a new building performance factor table. So this does have an impact on the percentage improvement. So we are looking at different tables to see what the total impact of the different tables are. But we'll just leave it at that for this slide. So taking the design against the 2013 baseline and the 2019 baseline, our results are the following. We, as you can kind of see in this table, we have the 3 sample projects, and we have on the left bar, it's the design against the 2013 with the right bar of the design versus the 2019. So as you can kind of see, we met that 30% below baseline for the 2013, for the design against the 2013 baseline in all 3 sample projects. But on the other hand, the 2019 didn't perform nearly as well. We, in 2 of the sample projects, we didn't even beat the baseline at all. It's under 0%, with the hangar being the only building that performed better, but still just over 10%, not anywhere close to that 30% requirement. So when we looked at that, we were not impressed with the design. We looked into see how we might be able to hit that 30% mark. And one of our possible solutions was to use on-site renewable energy generation. Just theoretically, if we use that in our project, would we be able to hit that 30% mark? So ASHRAE has a little blurb in their PRM section where they say if you meet this criteria, if you use this much amount of on-site renewable energy, then you will be able to use this new percentage improvement equation. So we looked at that, we applied some numbers, and we basically came up with an average of maybe 7 to 8% of the total building energy consumption. If that is converted from renewable energy or converted to renewable energy, then we would meet this criteria and we would be able to use this new equation, which really applies that renewable energy threshold and applies a constant renewable energy factor. So anything above that renewable energy threshold does not count toward that equation. As you can kind of make out in that equation, it's the performance building energy consumption subtracted from the performance energy building consumption with the non-renewables in there as well. So the idea behind this is that it promotes direct energy use reduction, but it also doesn't promote offsetting energy efficiency with renewables. So you couldn't use lower U factors, lower HVAC energy efficiency. So it's promoting using high efficiency equipment while also using renewables. So when applying these numbers, when applying the renewable energy factor, we came up with the following result. So in all three cases, we're now beating the baseline in the 2019 version, as you can see with that far right bar. However, none of them hit that 30% mark. They improve upon it by close to 10%, but even the hanger is at 20% below the baseline, not close to that 30% mark. So the impact of this is going to be significant because we are not meeting that 30% in any of our cases, and even using higher efficiency equipment, I'm not sure if we would be able to hit that 30% mark. So the CFR, as I mentioned earlier, states that the design must have the highest level of energy savings while being life cycle cost effective and meeting 90.1. So it's basically saying that we don't necessarily need to meet that 30% mark as long as we are LCCEE and complying with ASHRAE 90.1. So some cost and design impacts for future projects, energy modeling software that might have a difference in determining that calculation. As I mentioned, we're using ASHRAE or Trace 700, and as I've talked with the Mobile district on this, and both of our districts are kind of moving toward Trace 3D Plus, which is a more detailed software. It has more inputs and outputs. However, it still kind of has its own quirks and issues, which might impact the final calculation. Another one of the impacts is the introduction of the unregulated energy consumption loads into that final equation. And we did look at the impact of adjusting this number up and down just to see how much its impact is on that final percentage improvement equation. And it was not significant. I mean, it affected that final number by a couple percentage points by doubling or having that receptacle load number, but it wasn't a major impact. So I'm not sure how close that would get us to, if we had more accurate receptacle and process loads, I'm not sure how much closer that would get us to that 30% mark. Some other impacts of 2019, I mean, as I kind of briefly talked about, there were new mandatory and prescriptive requirements. Mandatory requirements, that's all compliance paths. Prescriptive, that's just the prescriptive path. So we also looked at the cost impact of applying these new requirements, and we talked to our in-house cost estimator, and we came up with a number of about $5 to $10 per square foot increase, which is about 2 to 4% of the total building increase for the JBSA COF. And most of that number is just coming from the new lighting requirements, just using higher efficiency lighting, meeting the new minimum requirements for that. So overall, I mean, if we use higher efficiency equipment, we might be able to meet that performance rating method compliance path with the sample projects at least. But if that's not an option, if we are not able to comply with the PRM, then we would have to look at other compliance paths, which would be the prescriptive or the energy cost budget, which we did look at that to an extent, and we did find that it was a lot easier to meet those paths. With this prescriptive, at least, it's just meeting the individual requirements of each section of 90.1. And then with energy cost budget, it's another energy modeling compliance method. So there would be a little more work involved in designing a separate baseline, but this baseline is a lot easier to beat with our design versus the new PRM baseline. So some additional information that wasn't covered in our research. The U.S. Department of Energy ran its own energy savings analysis for both the 2016 version of 90.1 as well as the 2019 version. And they were looking at the energy savings from the new prescriptive path and the new requirements of that prescriptive path. And they found that there was about a 10% improvement from each version of ASHRAE from 2013 to 2016, and then subsequently from 2016 to 2019. And that more or less met our findings for the most part. The other paper that we looked at was put out by ASHRAE. This was challenges with the new 90.1 PRM. And it seems like from reading that paper that they came to the same conclusion that we did, which is it's a lot more difficult to meet this new PRM compliance path versus using the other paths. They're specifically looking at the PRM against the ECB, the energy cost budget method, and they found that the difference between those baselines was up to 30%, which again was kind of in line with what our findings found. The ECB ASHRAE 90.1 analysis report was put out, I believe, maybe a month ago, and that was by our team in Savannah as well as the team in the Mobile district, and kind of goes over what I've been talking about this presentation, which is our analysis and our findings. And we also put out a point paper to send it to headquarters to see if and what changes could be applied to the CFR. We mentioned removing the 30% below baseline mandate, which may not be feasible, but it seems improbable now with the new 2019 version of ASHRAE to meet that 30% mark. And we also put in our paper to allow the adoption of this addendum BV, which is the new addendum with the new building performance factors, which again aren't significant. The changes are about 5 to 10% of the current version of 2019. So it may or may not help with the final percentage improvement, but it is worth taking a look at if ASHRAE did put it out after the original version of 2019. So overall, we found it a lot harder to meet that 30% mark established in the CFR, though it is still possible to meet the CFR requirements as long as one of the compliance paths is met for 90.1 2019, and if that design that meets the compliance path is also life cycle cost effective. So are there any questions?
Yeah, this is Jamil Hernandez from G9 headquarters. Okay. I do have a couple of questions, but sorry to say that I did miss the introduction. But I did catch from your presentation just now stating that there's a difference between going and using the energy budget model by the performance rating method, and that between them there's about a 30% improvement in performance.
Yes. So
if that's the case, can we say if we go and use the performance rating method, we are indeed complying with the CFR.
If we use the performance rating method and we beat the baseline, then we are complying with ASHRAE, which in turn means that we are meeting the CFR. We're not meeting the 30% mark. That only applies if it's not life cycle cost effective, if that makes sense. So the ECB is an alternative method that's not listed in the CFR's percentage improvement equation.
Yeah, this is Bill in Mobile. The CFR specifically says you have to use the PRM method for the 30% reduction, which I was with you, Emil, on that one. I thought, well, if we can show it some other way, that would be great. But it's the way it's written is it specifically says we have to use this PRM method. So
it has to be PRM and 30% above the PRM method.
Right, if you can be life cycle cost effective into it, which good luck with that.
And so I'm not as familiar with the 2019 version of it. How is it actually looking at when we discuss the whole life cycle cost, right? Feasibility portion of it. And so we know things like building envelope, right? There's a point of the diminishing return, but at the same time, there's a benefit in reducing the overall mechanical systems sizing, which leads to more efficiency. Has that changed significantly from the 2016 version to the 2019 version, so that if we will target something like being 25% or 30% better on that end, on the building envelope, would make it not cost effective?
I'm assuming so. You're talking about the changes in U values from 2013 to 2019, because we skipped over 2016 in the CFR language at least. So you're asking if that
So
would
we
make
never
it
adopted 2016, is what you're saying. We never adopted 2016 version.
No. So yeah, I mean, we didn't specifically look at whether or not the new U values would make, if the cost difference between implementing the new higher efficiency U values and efficiencies would make the building more life cycle cost effective. But as long as it meets one of the compliance paths of 2019 and it is life cycle cost effective, then it would meet the new CFR. I hope that kind of answers your question.
Yeah, Edward put a thing in the chat if everybody wants to read it right out of the CFR.
I figured that would help a little bit. The other thing that I would say is something that you mentioned, Alex, was hopefully it's that's very nice to think. I hope we can change the 10 CFR 433 through our pilot projects and our research and all the other things that we're doing. But I don't believe it's going to change anytime soon. So for the next year, we will have to try to meet these requirements. And specifically, you can just look at UFC 1-200-02 for the requirements specific to the Army, Navy, and Air Force. Feel free to read 10 CFR 433 plus 10 CFR 436 is another good read. And then the NDAA 2022, but that's like 1,000 pages. So, I mean, and it's a little bit dry because it's law. But anyway, but we can have a discussion on that too if you want to get into the details. But this is going to be a difficult benchmark to hit. It really is.
Well, from the standpoint of the program, all we got to show is that we did the the correct analysis of alternatives, right? In that we selected the best and cost-effective measures, and and if it's not feasible, then we are justified by the fact that we just couldn't get there, uh, you know, based on the life cycle cost assessment portion of it. Now, what we need to, at least on my end, and what I've seen working with projects, is to ensure that from the get-go, 3091s are written in such a way that any betterments are catch within the same, so that there's some cost built into the construction program to make some of those efficiency or added efficiencies uh, cash flow within the project as well.
Yes, we're looking at that on incorporating certain things into the 1391s that would then the analysis would not be needed on the life cycle cost effectiveness if it was in the 1391. But we haven't figured that out yet either. I think we're going to
Correct,
have
and I
to
think
see what happens with a lot of our projects and see what data we collect, since this only started 2 weeks ago.
correct, but I think that that's going to be really, really necessary, because more often than not, um, what went into the 1391s wasn't specific enough, and it was left to a project team and left to the bidders to submit any betterments. And then we were comparing apples to oranges. So there wasn't truly two projects or two proposals from any contractor that were indeed, comparing apples to apples. So that doesn't, facilitate that, right? So I don't know if it's going to be more of a writing performance based objectives within it, like leak rates and stuff like that, minimum acceptable leak rates, um, whatever that may be. But I think there might be an opportunity if from the get-go, because more often than not, what happens is that even if they write something, as there's cost increases and scope creep in the projects, and we are now facing the reality of the additional costs from inflation, then something's got to give, right? And usually it tended to be some of those efficiency measures as well.
Yeah, I would agree. I like the idea of the betterments. I like the idea of the people on this phone call and the designers and the COSs all look at this and brainstorm creative ideas or new ideas within the framework of doing it correctly, with the LCCA and everything else, but coming up with those solutions to try to meet that 30% reduction over ASHRAE 90.1 2019. I hate to think that we're just meeting the baseline of ASHRAE 90.1 when the goal is to really have a lot of energy reduction. So that's kind of my thought on it. It's going to take a lot of smart people thinking about this and coming up with solutions, and a lot of mechanical engineers working with our architects and electricals to come up with solutions for this, because I think it's going to be a difficult for our designers.
Yep.
Edward,
Quick question.
Just before you go off, just understand, meeting ASHRAE 2019 is doing 40 or 50% better in some cases than meeting ASHRAE 2013 version of 90.1. So
I concur.
we are cutting lots of energy out. It's not like we're not just meeting it is not going anywhere. It's not, we are moving forward just by meeting it. So just it's saying that not doing the 30% is not making progress. That's not true. That's not a true statement.
You are correct. You are absolutely correct. But this is a big jump on changing our goal line. I mean, previously we were meeting the 30% energy reduction requirement, and we had a checkbox at the command energy brief. When we talked to the ASA, we had that checkbox. Those checkboxes are going to go away on our projects if we don't hit
Yep.
our new goal, which is extremely difficult. So yeah.
So one question on my end is, ASHRAE used to publish the Advanced Energy Design Guides, right? And for achieving 50% over, I think it was the 2013 version of it, right? Um, how
They still
much of
do.
that has how much of that has been incorporated into our standard building practices, if at all?
I don't think I have the information to answer that question. I'll think about that.
Yeah. So they had within the prescribed measures that they have already identified as being cost effective. Things like continuous insulation, exterior continuous insulation values, um, a lot of passive design type of approaches as well, and then the mechanicals. And within the mechanical section of it, they did provided multiple avenues or systems, right? So it wasn't prescribed as a single system to be used on a building of X amount of size, right? There were several options within it. I think that could be a great starting point for us to evaluate how much of that do we actually incorporate and then verify against whatever premises we use to compare the new model, the new bit, the new code and the models, and see where we at. Perhaps, like you're saying, right, in the progress between versions, the code might have improved by about 20%, let's say, right, from 2013 to 2019 version, and perhaps 50% is not going to be 50%, might only be between 25% or 30% or 20 to 30%, right? But at least, we can use that and then understand where we at and how much of that is actually applicable to the construction standards going forward.
Looks like Ed jumped off, but yeah, I agree with what you had said. I mean, are there any other questions? Just if Ed doesn't jump back on.
I just want to, remind folks that the building performance factors and whatnot are all based off of prototype buildings that ASHRAE developed in collusion with the DOE. So you can always go on DOE's webpage and see what those buildings are and see what they did to and the assumptions they made. And depending on what you put into your model and what you assume will vary the outcomes. And I know I've talked with other folks where, I forget, Bill, if it was Bill Durham, if it was you, I was speaking with that down south, or at least in y'all's areas, that very often you get a flat rate for your utility structure, whereas up here I've dealt with public utilities where it's a very complicated tariff with demand charges and demand charges that ratchet, and it can affect your how the calculation comes out, especially since the the way the law is written is that we have to do a energy use reduction. However, the 90.1 PRM in the 2019 is based on energy cost. And I know ASHRAE tried doing it to normalize it, and also so that you didn't have to do multiple energy models between just trying to meet ASHRAE versus using a third-party rating tool like LEED. So it lets you kind of work together with the third-party tool. However, again, it's based on energy costs, not energy use, and that can, at least in my experience, can be different.
Yeah.
Over.
Well, where I see the issue coming with energy cost, I believe cost takes into effect, or takes into account, and it's, for lack of a better term, the quality of the energy you're getting. In other words, heat can be used anywhere you need heat, but it can't make motion and it can't make a chemical reaction for you unless you've got a good temperature difference. You know what I mean? It's second law of thermodynamics. I was talking with a young man that works here, and he worked for Southern Company for 10 years before he came to work for us. And he was talking about their best generator, which is a gas turbine with a steam boiler piggybacked on it. The best efficiency they've ever gotten out of it is 48%. In other words, for every BTU you put into it, you get 48% of a BTU out in the form of kilowatts of electric power. So with the vast majority still, I think, of the country's electricity coming from fossil fuels and things like that, running generators. And I know there are places where hydro does really well in the Northwest, and we're building solar infrastructure and things like that, although solar goes away at night. The electricity is more expensive because it's a much higher quality. You've already paid the price of the second law back at the plant. Using it to heat a building is, in my opinion, unless you're using a heat pump that's a fairly efficient system, and you've got warmer outside temperatures or warmer heat source temperatures, you're wasting that valuable electric power that can make things move or do other things besides just produce heat, making heat for a building in the wintertime. So I think that cost that ASHRAE is following here is taking into account not just how much energy you're getting, but its usefulness. That's why electricity is typically more expensive than like natural gas, because gas is just producing heat when you burn it.
All I know is that up here, I have a gas boiler.
Uh-huh.
I just have a little pump that moves the water around in my house.
Uh-huh.
The few cold days of winter we got in December, and you get a note from PECO, a text message from our Philadelphia Electric Company saying that PJM, the company that runs the grid, is telling everyone, hey, back off on your heating back off on your
Uh-huh.
you're gonna have some trouble here. And it's like, man, I'm glad I got a gas boiler and just a KW pump.
Yeah.
Versus like my ma, who's got all electric. So if that's sending out text messages now, just wait until we're all on electric.
Yeah, I'm with you. I have a heat pump in an all electric house, but I do have a little fireplace that it's come the really cold days. I started up here, and Mobile does have really cold days occasionally. We get them once a week in December and January. So, so having that something we can burn definitely heats the house a lot quicker than the heat pump does. So
This is Jamil Hernandez. I think Michael Cannon brought a excellent point, which is that most often than not, the main issues that we face when designing new construction and projects is not necessarily the expertise of the team, of the design team involved on the project, but the constraints, artificial constraints placed by the DPWs and placed by the personnel, the installation personnel, because they may not understand the new technology and don't have the expertise, or B, they are just biased towards given expertise as a subset of training. Um, and that also leads to another part of the conversation, which is the commissioning of the systems and the training of the systems. So sometimes they are open to new systems, right? But because they lack the expertise in control systems and maintaining uh, the more control intensive uh, HVAC systems or heating systems, right? They often either oppose afterwards after having an experience with a given building and then defaulting to the point of no, we need the dome system that it's least efficient, but it's what we can support.
Yeah.
I'm the FRCS manager at G9 on the building side. Um, and that is something that we usually see. That is my experience also working prior on an installation, right? And that was the main concern from the personnel. But I think at some point, as a program, we're going to have to make certain determinations and just have a frank conversation as to are you able to support it? Yes or no. And if not able to support it, then how are we going to support it? Is it going to be through a contract or how is that going to help? How is that going to get done, right? It's kind of like with the ESPCs and UESCs as well. But, like it or not, when we get into that whole conversation with controls are now mandated by ASHRAE.
Hmm.
So it's something we can't get around it. Technology has evolved, personnel hasn't evolved with it in
Right.
their trainings, right? And certifications. And oftentimes when we do train them up, then they leave federal service because they can actually get a better job, better paying job outside, right?
Yeah.
We may not be able to fully fix that, but we need to acknowledge and have perhaps top cover, and I mean from headquarters down to you guys at USAs, regarding, hey, how much do we push towards getting the right systems to optimize the building? Um, you know, I would default always towards a better building envelope, passive designs, strategies, to heat the building passively during the winter time and then rely less on the equipment. Hopefully, kind of right size the equipment and make it smaller and all that stuff. But in the end, we're always gonna end up with having a more advanced system than what the field personnel um, may be able to support. And then we're gonna have to figure out, do we add more training within the enhanced commissioning um, portion of lead or some of those requirements, or how do we get about that, right? And I think that's a point in the conversation that needs to be had. Over.
And Emil, this is Bill in Mobile again. The other issue is we need to make sure our energy conservation measures are not resulting in, for example, my biggest example, because I live in a hot and humid climate, is buildings here need to be pressurized with conditioned air so that you leak the good air out, you don't leak the bad air in, which results in sweating and sick building syndrome. In some cases, it'll corrode. You start getting structural members corroding and things like that. You can damage a building very quickly by having it negatively pressurized in a hot and humid climate. So, but doing the air conditioning correctly raises your energy use. It's just going to do that. And you have to decide, okay, do I want to pay for the energy now, or do I want to pay to build a new building in 10 years? So,
Okay, that's part of it, because buildings are becoming also more uh, um, energy intensive by itself because of the reliance on controls and other stuff, right? The more
mhm,
um, ele- the electrification of it as well, right? That requires
mhm,
a little bit more demand, and in the end, we got to cool it a little bit more as well, as a result of having more computers, more indoor training systems within the Army facilities, and the likes of it, right? And we're shifting away training that used to happen in the field towards the building, right? By using
Right.
more simulators and stuff like that. So that is also happening, and we need to acknowledge that. Buildings are becoming, it used to be a 100 amp service panel at a home. Now we're in 200 as a standard, right? So that the same is happening also on the building side. But things like having a dedicated outside air unit, right, with the energy recovery and all that stuff, that helps. But it may not be, you know, um, fully undo what you're saying.
Right. Well, like a dedicated outside air unit, we always want to recover energy that's being exhausted. Well, when we get right down to it, to pressurize the building, we don't need to be exhausting all the air we're bringing in. We need to exhaust a portion of it necessary for like toilet rooms and stuff like that. The rest of it, we need to let it leak out the walls, and then, and we do, because it all ties into with the air barrier requirements in ASHRAE. I think right now the UFCs allow the Air Force, you can have up to 0.4 CFM per square foot of outside surface area of a building when you test it at 0.3 inches. Well, at 0.1 inches, you get the square root of 1/3 of that.
Mhm.
Or I think it's about 1/3 of that. Or no, it'd be the square root of that. Anyway, you get that much of allowable flow to maintain that 0.1 inch pressure difference, so you can still open the doors against the pressure difference or close them against the pressure difference, but at the same time you resist about a 10 knot wind, so, and don't again bring in hot, humid, unconditioned air through the walls, through cracks around the windows, through cracks around the doors, things like that, that then ends up condensing on cold surfaces inside the building. A lot of times inside walls, studs behind wall, wall board and things like that, that grows. If you let it happen long enough, it's going to grow into mold and mildew and make people sick and do all kind of other bad things. And so keeping the building pressurized is in a hot and humid climate is absolutely important. If you're out west where it's dry and the wet bulb temperatures down in the 50s all the time, it's a whole different story there. But if you're along the Gulf Coast and Florida and the Kwajalein Atoll and Hawaii and places like that, anyway.
So
All right, Bill,
basically,
thanks for that.
Daniel,
let me
I thought
let me
you-
bring this back, everybody. This is Ryan Murphy from USA's headquarters. I want to thank Alex. You can find him in the global as John Ortiz. If you have questions or follow-up or want to continue your conversation there with him, please call him. He would love to hear from you and talk to you about more of this. Alex, where can people find the latest information? Can you just highlight that one more time before we jump off?
Yes. So we both, our district, Savannah and Mobile, both had a analysis report, which is on the ECB website. The new version of ASHRAE has all the information as well. The challenges with the new PRM is a paper that you can find pretty easily online. And the DOE energy savings analysis as well are pretty relevant pieces of information.
Perfect. All right. Thank you so much. Thank you, everybody. We will publish this recording at a later date. And if you have any questions for Alex, please bug him early and often. So, all right. Thanks, everybody. Take care.
Thank you.
thank you all.